Good morning, student. Let's start today's class. Today we will discuss about the second engineering aspect of the solar power plant, which is thermal storage for solar power plant. In previous classes, we have already studied about the first engineering aspect, which is collection of solar thermal energy, okay, or collection system. Today we will study about thermal storage of solar power plant. That means the storage system. Okay, the the solar panel performance is limited by durable season. Uh, uh, the solar plant performance is limited by a diurnal, seasonal, and weather related variation in the incident solar radiation. That means the solar performance or the solar power plant performance is influenced by the bad weather or the winter weather. Okay, when the sun shine is not adequately sufficient, or the sun radiation is not adequately sufficient, that effect or that provide that provide some fluctuation or the effect on the thermal production, okay, in the plant. And to overcome this problem, okay, or the fluctuation, the solar power plant input may be backed by a backup device or auxiliary backup device that is using fossil fuel, okay, to generate thermal, okay, or burn fossil fuel to generate thermal, and or using storage device, okay. uh, and the and in economically manner, or in if we consider in economic or low cost, the storage is much better option than fossil fuel, okay. And uh, we we use the storage, okay, we use the storage or in a small scale. That means very often the fluid here the very often the fluid in the collector's field itself act as a storage medium, okay. When the temperature of fluid increase in flow and reach to the thermal storage tank and exchange that thermal energy to the tank. That means the fluid flowing inside, or the heat transferring fluid itself act as a collector to collect that thermal energy for a instant, or for a little bit of time, and after that it transform them to the storage tank, okay. And that storage tank, okay, the thermal storage media, that means here the spelling mistake is there, media, okay, correct that. The thermal storage media, okay, we use which type of media to store the thermal energy in our thermal storage is called the media, okay. Or what material we use to store the thermal energy in our storage tank or storage is called thermal media, okay. Now let's the type of storage media. First of all, sensible heat storage media, okay. That means the material which is used to store the heat, okay, store the heat in the storage, okay. uh, that uh, that is called sensible heat storage media, okay. For temperature up to 300 degrees Celsius, thermal mineral thermal mineral oil, okay, mineral oil, remember that up to 300 degrees Celsius, okay, that thermal energy stored in the storage using mineral oil and can be stored at normal pressure and it is the most economical practical solution. Okay, mineral oil, by using mineral oil. Okay, then synthetic or silicone oil available up to 400 410 degrees Celsius. Up to 410 degrees Celsius, the temperature is stored by using synthetic and silicone oils. Okay, and that to be pressurized and very expensive. These synthesized and silicone oil are very expensive, and also we should pressurize them to store the uh, 400 up to 400 degrees Celsius. Okay, next is molten salt and sodium can be used between 300 and 550 degrees Celsius at atmospheric pressure but need auxiliary energy to keep them liquid. That means this molten salt or sodium can also be used for storage of thermal up to or in between the heat in between the temperature 300 to 550 degrees Celsius. Okay, but here the disadvantage is that the auxiliary energy needed for keep them liquid means this molten state, to keep the molten state of salt or sodium, we should use an auxiliary energy. Okay, that is the disadvantage. For temperature above 550 degrees Celsius, ceramic fire bricks became a competitive option. Okay, remember this. For up to 300 degrees Celsius, what is the material used to store the thermal energy, which is mineral oil, and up to 410 degrees Celsius, synthetic silicone oil, and between 300 to 500 degrees Celsius, molten salt and sodium, and above 500 degrees Celsius, ceramic bricks. Remember these 4 points. Okay, next is latent heat storage medium. Latent heat means what? The amount of heat released or absorbed. Latent heat is the amount of heat released or absorbed at the time of uh, the at the time of the state of the state of the material is changed. That means when let's say one solid state is changing to the liquid state, at that time the amount of heat radiate or absorbed by that material is that amount of heat is called latent heat. Okay, so here in latent heat storage media, we use the phase changing material. Phase changing material. This phase changing material. What is this phase changing material? Phase changing material is that material which storage anonymous and which radiate or emit anonymous amount of heat when it shifted to the phase. Okay, or shifted to the other state. That means when that material is shifted or converted from solid to liquid, or liquid to solid, or solid to vapor, or liquid to vapor. Okay, that material emits huge amount of thermal energy. Okay, and this phase changing material have a high volumetric storage capacity. That means this material can store high volume of or high amount of high density of thermal energy. Okay, and and heat availability at a rather constant temperature. That means the availability of heat from that material is in a constant temperature is very huge. Okay, the energy storage system using the latent heat related on melting melting eutectic solid. Okay, eutectic salts or metals. That means this latent heat released on latent heat storage media, the energy storage system using the latent heat released on material. Okay, but it never carried out the lab because this eutectic salt or metals. Okay, melting eutectic salt or metal is very expensive according to the investment cost. Okay, it is very difficult to apply in a large scale. Okay, and heat exchange between the heat transfer fluid and the storage medium is seriously affected when the storage media is solidified. That means when that storage media, due to we use melting eutectic salt or melting metals, when that melting metals or eutectic salts solidified, that time the heat transfer from the fluid or heat transferring fluid to the storage media is seriously affected. Okay, so that encapsulation of PCM has been purposed to improve this encapsulation. That means insulating the tank from the outside environment. That means the outside environment temperature didn't fall any effect on that material. We should carry or we should take care of that technology or insulating the whole tank from the outside temperature. That's why we remain or we maintain the melting state of that material. Okay, and that material did not solidify anymore. Okay, this is the improvement or proposed improvement for this PCM uh, phase changing material storage system. Okay, thank you.